At all, let's continue our discussion. As per our previous discussions, we understood that a data warehouse could only store structured data. So, storage in a data warehouse is generally more expensive than on prem Hadoop clusters or cloud storage object. So, storage and compute in traditional on prem data warehouses are often tied together and therefore cannot be scaled separately. More storage costs came with multiple compute costs, whether you needed the compute power or not. So these are the fundamental problems we have with the existing data warehouse. But we also looked into technical components, what data warehouse is having, and how it will help us to store and process the data. So those technical components are still very important, but because of its closed architecture, we have these set of problems. So in order to solve these problems, we have data lake. So we have the concept of data lake. So before we go and even dive in what is data lake, let's try to understand briefly about Hadoop systems. So originally we were using Hadoop, an open source distributed computing framework, and its HDFS file system component to store and process large volumes of structured and unstructured datasets across clusters and inexpensive compute nodes. But it wasn't enough to just be able to store all this data. You won't be able to run analytics on it. So, running analytics on top of the data, which is stored in clusters, which is distributed and stored across the clusters, was difficult. Also, writing MapReduce jobs was verbose and complex. So many analysts are more comfortable writing SQL than Java. So Hive was created to convert SQL statements into MapReduce jobs. So in order to use the job for analyst, so now this diagram is looking like this, where analyst will be writing SQL and I will be taking care of converting that to MapReduce. To write SQL, a mechanism to distinguish which files in your storage are part of a particular dataset or table was needed. So this resulted in the birth of Hive table format. So it was a basic requirement when you're writing the SQL. You should be able to understand or recognize set of files which belongs to a particular dataset or table. So the Hive format looks something like this, where it's an hierarchical directory structure which will classify the files and put that into a particular or respective folder. So that group of folders or a particular directory will be represented as a table. So you can, this diagram clarifies things in much detail. So you can see these dataset files. So it belongs to a particular table. So this metadata information of which folder is holding which dataset files is stored in the Hive meta store. So over time, people moved away from using Hadoop cluster to using cloud object storage. So MapReduce also fell out of use in favor of distributed query engines such as Apache Spark, Presto, and Dremio. So what did stick around was this Hive table format, which became a standard in the space to distinguish the files defined in the storage. It will keep track of all the files and it will tell you which set of files belong to which table. So that becomes the de facto standard across the industry in order to recognize the tables which is stored in the storages such as AWS S3, Google GCP, or Azure Blob Storage. But there is a problem with this approach also, where we are using this Hive Metastore. Problem is storage required more network cost in accessing the files which is stored in AWS S3. Coming to the cloud storage, the cost will not be for the storage. You can just go and store the files in the blob storages like S3, GCP, or Azure Blob Storage. So you'll incur cost if you want to transfer that data from source A to destination B. Cost will be incurred when you transfer the data. So the Hive format architecture didn't anticipated this. So the user is reading here, he will be reading any file, it can be JSON, XML, or PDF, which is stored in S3. When he requests for the file from these blob storages through this Hive metastore, so you'll be transferring the data. That data transfer cost for the objects which is stored in the blob storage is very expensive, which led to expensive network calls due to Hive dependency on the table folder structure. So because the Hive is maintaining a folder structure kind of a hierarchy for the files or the data. So whenever we are making a network call, so we'll be requesting for a table. So basically the file, all the files which is residing inside this directory. Whether the analyst need that particular set of data or not, we'll be making that call. That call results in a high data transfer cost. So the analyst will be pulling in all the data which is stored in that particular folder, which is maintained by this Hive Metastore. We got the problem. We have this table format that is Hive Metastore. So it results in higher data transfer cost between the blob storage and the user. So this forms our data lake. So let's try to understand some of the advantage and disadvantage we have with the data lake. Lower cost. So the cost of storing data and executing queries on data lake are much lower than in the data warehouse. This makes data lake particularly useful for enabling analytics on data whose priority isn't high enough to justify the cost of a data warehouse, enabling a wide analytical reach. So the user can go and still query the data which is stored in the S3 irrespective of the data transfer cost. If you are just ignoring it, so you don't really have to go and rely on a data warehouse or buy a data warehouse in order to just analyze the data. The data can be stored in the S3 or any blob storage, and you can leverage the Spark or Presto or Dreamio to go and analyze that data. So stores data in open formats. In data lake, you can store data in any file format you like, whereas in data warehouse, you have no say in how the data is stored, which would typically be a proprietary format built for the particular data warehouse. This allows you to have more control over the data and consume the data in a greater variety of tools that can support these open formats. So here you can see you can store it in any format, JSON, XML, PDF, or you can store it in Parquet, ORC, or Avro file format also. So you can choose that. So based on your need, you can store the files in the blob storage and you can execute the queries directly on the blob storages. And it also handles the unstructured data which is not handled by the data warehouse. But there is one big problem with a data lake, that is lack of ACID transactions. So one notable drawback of data lake is the absence of built-in ACID transaction guarantees that are common in traditional relational databases. So in data lakes, data is often ingested in schema on read fashion, meaning that schema validation and consistency checks occur during the data processing rather than at the time of ingestion. So what this statement is actually saying is, so if you want to do update, merge, delete these logics on top of the data which is stored on the blob storage, you can't do that. So one thing what you can do well is you can just go and read the data which is stored in the blob storages like S3. You can only read the data, but you can't modify the data which is stored in the blob storage. So that is one big drawback we have with the data lake architecture. So hope you got at a very high level how the ecosystem of Hadoop evolved over a period of time to become a data lake, and how Hive become a default table format in order to manage the data which is stored in the blob storages, and the problem we have with the data transfer cost if we are still going and sticking with this Hive table format, because it will point to a directory structure. When analyst calls the data, they will pull everything which is stored inside that directory structure. So that will result in high data transfer cost. Another problem is with respect to the asset properties which data lake do not provide. Basically, it won't allow you to make changes to the data which is stored in the blob storage. So hope you are clear with the problems we had with data warehouse and the solution we came up with data lake, and also the problem we have with the data lake. So with this, I will close this lecture. So see you in the next one. Thank you.